Good morning, Kennedy.
Good morning.
It's kind of cold this morning. It was 9 degrees when I walked my dogs this morning. You're welcome to unmute yourself until class starts. Good morning, Cheyenne. Did you get your printer problem taken care of? You're welcome to unmute yourself if you wish. The adapter I told you about at Best Buy, they may also have them at Walmart. I'm not absolutely certain about that, though. If they do have them at Walmart, it'd probably be a little cheaper. Oh, okay. I see that you don't have a microphone. Did the adapter work for you? Yes, good morning. A chilly cold one at that. Oh, well, good. Situation taken care of, money not spent. So that's a win-win. Since I'm the only one in the room, that's why I'm able to get away without wearing a mask. Maybe someday they'll no longer be needed. Good morning, Eduardo.
Good morning.
I want to, for the three of you, I want to try an experiment, and you can either give me a chat notation, or actually there's an opportunity here in Zoom where you can give us a thumbs up or a thumbs down. I want to try 3 different lighting situations and see which way you can see the board up here, read what's on it best. So let me change some lights around. Okay, this is lighting number 1. Lighting number 2. Lighting number 3. And lighting number 4. Which of those is best for you? Number 3, 3 and 4, 3 and 4. Okay. Good morning, Lauren. Good morning, Desiree. All of you, please read the chat comments that just got here. Okay, let's see. I think that was number 3, if I recall. So we'll try it on there today and see how that works. It's time to begin. And today, I would suggest that you have from your handout packet this page, which has primarily these rules. We've kind of passed by this, but these are still very relevant to what we're doing today. Also, now this doesn't look like yours, but these are items A, B, C, D, and E on the page on the back side of this other one. So if you would have that out as well, we've actually looked at this page previously, and I've got some scribbles on your page that you got in addition to what you see here on my screen right now. Now, I want to spend a little more time today working on some problems on factoring, because factoring is so important to being successful at everything else. So I came up with yesterday 3 additional pages of potential factoring problems that we can go over. We're not going to do all of them. That would take entirely too long, and I don't have that much time. But I am going to do some of these down the left edge, and perhaps number 22 or 23 that you see down here at the very bottom. And I'm going to kind of write over the top of this other stuff. So if I were to do number 5, a squared plus 10a plus 21. And I'm going to go ahead and put the equals 0 on these because we've already learned that skill. Now, as I look at this, I've got a 1 and a 1 for the factors of the number in the a location, as in a squared plus bx plus c, okay? And my factors of 21 are 1 times 21, 3 times 7. That's the only ways you can get 21. Now, this tells me it's a same sign problem. So after I multiply, I've got this little curve there. I actually probably should use a V like that. Those are the only factors of this. And because that is a plus, that means both signs of my problem are either going to be plus or minus. In this case, both signs are going to be plus. So my answer then is going to look something like that. Now, I can try the 1 and 21. Well, 1 and 21 are, when I multiply them, are going to give me a 22, so that won't work. But I can try the 3 and the 7. 3 times 1 is 1, is 3, duh. 3. I told you I make silly mistakes sometimes. And a 7 here. Well, that's a plus, and 3 plus 7 is 10, so it checks with this. Our sign is plus, and everything is plus. Of course, this sign translates to here, this sign translates to there. So my two sets of pairs, when I put the variables back in then, are 1x plus 3 and 1x plus 7 equals 0. Now to finish this, we have x plus 3 equals 0 and x plus 7 equals 0. Subtract 3 on both sides, we get x equals 3. Subtract 7 on both sides, whoops, negative 3, my mistake. X equals negative 7. And in set notation, then your answer would be the set containing the elements negative 3 and negative 7. Okay, let's go to the next problem. The next problem, y squared minus 10y plus 21 equals 0. Well, you know what? We've got the same numbers in this one we had in that one. The only difference is here I had a plus, here I had a minus. Once again, my answer is going to take the form, in this case, minus minus. And because that's a plus sign down here, I'm going to add my two cross products. Once again, I've got 1 and 1. And over here, I've got the 3 and the 7. And by the way, 3 and 7 make 10, so that makes kind of easy to figure out. Well, 3 times 1 is 3. 1 times 7 is 7. 3 plus 7 is 10. It checks. In this case, that's a negative, and since they're same signs, both of these got to be negative, and here would be your factored pairs. So you would have 1x minus 3 and 1x minus 7, and your two solutions would be x equals 3 and 7, positive 7. So you would have then 3, 7. Okay. As you see, the only difference in these two, this tells me that both signs are going to be the same, and this tells me which sign it's going to be. So let's go into the next problem on here. Y squared minus y minus 12. Okay, in this case, I have a negative here. So when I get down to this stage, I'm going to have to subtract because this implies that my two products are going to be different signs. One of them will be plus, one of them will be negative. So 1 and 1 again. In this case, the multiples of 12 are 1 times 12, 2 times 6, 3 times 4 in those cases. So remember, we're going to subtract the cross products. Do any of these produce a 1 when you subtract them? Well, 3 and 4, if you subtract them, they produce a 1. 2 and 6 would give me a 4, 1 and 12 would give me an 11. So it becomes very obvious what my pairs of values are, and since these are 1s and 1s, it doesn't matter what order those are in. So here I have a 3, here I have a 4, and I subtract them and I get a 1. Now, the important part of this process, this 1 has to be a negative. And once again, I mentioned this yesterday, we go back to the old rules for adding and subtracting integers where we take the sign of the biggest, subtract the little one from the big one, and take the sign of the biggest. Well, the sign of the biggest, or the one with the greatest absolute value, has to be the negative. And this one then has to be the positive by default. So because negative 4 and positive 3 produce negative 1. This translates up to here. This translates to here. We put in the x's. So my two pairs are x plus 3 and x minus 4. Those in turn produce x equals negative 3 and x equals positive 4. As such. Now, that's just the fundamental ones where you got 1 as your leading term. Now we're going to move into some problems where 1 is no longer your leading term. Oh, I want to do number 17 before I go into other values. Number 17, x squared minus 8x minus 9 equals 0. Okay, in this case, I'm going to have a 1 and a 1 here. That tells me that I'm going to subtract signs or subtract values. And the factors here, I have a choice of 1 times 9 and 3 times 3. Well, 3 minus 3 would be 0, so it doesn't work. 9 minus 1 gives me 8, so that's my pair. I cross multiply them. That's a 9, supposedly. And I get an 8. Now, this 8 has to have a negative sign. So sign of the biggest is this 9. That one's the positive. It goes up here. This one goes here. Put in the x's, and we've got our ordered pairs. X plus 1 and x minus 9 equals 0, which gives us values of x equals -1 and x equals positive 9. Okay, so you see in these two, although we had to subtract, this had to be the sign of the biggest. And yes, I know that sign of the biggest is not technical mathematical terms or correct grammar, but it works. I'm going to switch to another page now. And this time we have some problems that have numbers other than a 1 in the front term. So I'm just going to work this number 40 right here. Okay, now that's a cube. We're dealing with something we haven't done before. That's a cube. Now, with this cubed, I've got an r cubed, an r squared, and an r to the first. There's a hidden first power here. That means I've got an r in all of these powers that I can factor out. I've got a 3, and a 6. So a 3 will also factor out of all of these. Well, that leaves me here r squared minus r, 1r, minus 2, and then equals 0. Okay, so we've got this thing now. We still have to factor this part. We just bring down this 3r. If you want to put it in parentheses, you can, but it's unnecessary. Now here, I'm going to have a 1 and a 1, and a 1 and a 2 are the only combinations I can possibly have. 1, 1, 1, 2, and because that's a minus, I'm going to have to subtract. So here I get a 1, here I get a 2, and I get a 1 answer, which is correct. That 1 is a negative, so sign of the biggest is this 2 right here. So there's my sign there, and the sign of this one would be a plus. So here, put in the x's, and I realize I'm writing kind of small right now, and I'll try to do better. So what have I got? I've got x plus 1, x minus 2 equals 0. As you see, this meets the requirements for different signed products. Okay, here we go. So x equals -1 and x equals positive 2. So -1, 2 is your solution set. Now, this factoring out, oh, wait a minute, I'm not done. I forgot something. I've still got this 3r out here in front. If 3r equals 0, if I divide both sides by 3, then r still equals 0. So I also have a value of 0. I almost messed up. Well, actually, I did mess up. Of course, none of you will have ever made a mistake like that, right? Okay, well, let's go on. Number 41 is a similar problem. On number 41, we're going to take an x cubed out of all three of these. Which leaves us x squared plus 4x plus 4 equals 0. We bring down the x cubed. This thing factors into x plus 2, x plus 2. You see that? 2 times 2 is 4. 2 plus 2 is 4. Okay? So then our answers here, if x cubed equals 0, then the cube root of x cubed and the cube root of 0, x equals 0. For this one, x equals -2. For this one, x equals -2. Your solution set is 0, -2. You only write the -2 once. Okay, most of the rest of them are on this page, are problems where you have to factor an item out before you can factor the rest of the equation. I'm going to go to my next page of these. Okay. And here I've got problems that, again, have first terms different than 1. Let's work number 29. 3a squared minus 3a minus 60. I can factor a 3 out of all of this, leaving a squared minus a minus 20 equals 0 equals 0. Okay, now, in this case, what are my choices here? 1 times 20, 2 times 10, 4 times 5. Those are my choices. Now, I'm going to have 1, 1 on the front end. So, and I'm going to have a subtract from my cross product. So 5 minus 4 is 1, or 4 minus 5 is -1. At either rate, 4 and 5 are going to be my values. So I get a 4, I get a 5, and that gives me a 1 when I subtract those two. Actually, this is the absolute value, so it doesn't matter whichever one that I subtract. Now, I'll put it in front. This has to be negative. So I have to use the sign of the biggest rule. So here and here. And so my factored pairs, I've got this 3 out front. And then I've got x plus 4 and x minus 5. Now, if I set this equal to 0, 3 equals 0, that's not true, so we throw that 3 away. If there isn't a variable with it, it's a non-entity. It's just a multiplier. This one gives me x equals -4. This one gives me x equals +5. So my solution set then is -4, +5. There's one more that I want to work, and that's this number 33 down here at the bottom. I'll leave that one up for a few minutes, and we'll go ahead and work this one right over here. Okay, 100p squared minus 1300p. Wow, that's a big number. Plus 4,000 equals 0. That one looks a little bit, let's see, this is 100, not 10. That's a little bit scary. First, I look at my variables. I can't factor anything out there, but I can factor 100 out of all of this, giving me p squared minus 13p plus 40. Now this thing looks a whole lot more manageable. So I just bring down the 100. Here I've got a 1 and a 1. 40, I have a 1 times 40, 2 times 20, 4 times 10, 5 times 8, and that's all the choices that make up 40. Well, I'm going to add my terms. Do any of these add up to 13? Well, 8 and 5 is 13. So there's going to be my choice. And it doesn't matter because these are both ones, whether I, which order I put these two in. Here I get a 5, here I get an 8. That's positive. So I'm going to add, and I get 13. Now, this 13 is negative. And both of these have to be negative. And I can put the x's in there. So my factored pairs then, I've got the 100 out front, which will become a non-entity. Then I've got p minus 8, p, or yeah, I put x's there, it should have been p's. Hope that didn't confuse anybody. And p minus 5 equals 0. The 100 becomes a non-entity, so I get p equals positive 8. P equals positive 5, or in set notation, 8, 5. Okay? So hopefully that'll reinforce your factoring skills a little bit. And we'll pick up some. Actually, we're going to have to use factoring the whole rest of the semester. Now, those done, let's go into this. We've already done the zero product property. That's where I set these equal to 0 and do this. So we're able to just kind of move through those slides pretty quickly. Helps if I turn my clicker on. Also helps if I erase the board. There we go. Well, there's an example up here. I will go ahead and work that one. It has some merit to it. X times 2x plus 1 equals 15. Actually, did I work that one yesterday? I'm not sure. Well, anyway, I distribute this, so I get 2x squared plus 1x, and then I'm going to move this 15 over to the other side. Minus 15 equals 0. Okay, I've got a 2 here, so I'm going to have a 1 and a 2. I look down here. I've got a minus, so I'm going to subtract. My choices are 1 times 15, 3 times 5. Okay, so I want to come up with some combination so I get a 1 down here. Well, I'm going to deal with the 3 and the 5, but it matters which order I put them in. If I put the 5 on top, then I'll get 10 and 3, which gives me a 7. If I put the 3 on top and the 5 on the bottom, then I get a 6 and a 5. And if I subtract 6 and 5, I do get 1. That 1 in this case has to be positive, so the biggest one is the positive, the smallest one is the negative. So here are my signs. So this thing factors into x plus 3, 2x minus 5 equals 0. Now we have to go ahead and use the zero products rule. X plus 3 equals 0. 2x minus 5 equals 0. This one we subtract 3 on both sides, we get x equals negative 3. This one we have to add 5 to both sides. 2x equals 5, divide by 2 on both sides, x equals 5 halves. So here are our two solutions, or in solution set notation, we have negative 3 and 5 halves. Okay, so here I just needed to make the point that you got to have 0 on the far right side. This is the same problem, except they've already moved. Well, that is the same problem. Okay, here's another problem. This one only has the 2 terms. Okay, that means there's a plus 0 hidden out here at the end. Now, we can take an 8 and an x out of both of these, leaving us 3x minus 1. Now we use the zero products property. 8x equals 0, x equals 0. Subtract 1 and divide by 3, or add 1 and divide by 3, so we get 1/3. Here are some practice problems, but I don't think we're going to stop on those. This we'll get to skip. Okay, the quadratic using the square root property. This is a major solution method. This is important. Now, this says if you've got a value that says x squared equals, let's say, 16, then x equals plus or minus the square root of 16. Why would it say that? If x squared equals 16, then x equals plus or minus the square root of 16. Well, it's because of that old thing that -4 times negative 4 equal positive 16. Positive 4 times positive 4 equals positive 16. Okay? That's why we have to have this plus or minus, because either of these statements could be true, and we don't know which or if both are true. Now, because of this business that a negative times a negative is a positive, that's also why, and we covered this before, that you can never have a negative here without it becoming an imaginary number. Okay, let's solve 3x squared equals 12. Well, first thing I do is I divide both sides by 3. It's easy. Now, if there were fractions up here, I might or might not. Depends on the numbers. Now, I take the square root of both sides. Just like we can multiply both sides or divide both sides by a number, or we can add the same amount to both sides, going back to my Libra scales example, we can take the square root of both sides. So I take the square root of x squared, and I take the square root of 4 plus or minus. Well, the square root of x squared is x. And the square root of 4 is 2 plus or minus. So plus or minus 2 would be your solution set on this particular problem. Okay, here's another one. X squared plus 25 equals 0. Now, there are two ways you can do this one, but we're going to do it by the principle of square roots method. I'm going to take this 25 on the other side. Uh-oh, when I take this 25 on the other side, I've got a negative value here. I've got to watch out for that. Now, I take the square root of both sides, plus or minus, and square root of x squared is x. I extract, well, they haven't done the extraction yet. So I've got plus or minus square root of negative 25. Now, I'm going to extract this negative to an I. Then I'm going to extract this 25 to a 5. And I've still got the plus or minus on that. So that means your answer could be positive 5i, or your answer could be negative 5i. And there would be your solution set, which actually, even inside here, you could write that this way. Okay, another one. Now, this whole parentheses is squared. So we're going to take a square root of this whole square parentheses, and then take the square root of the 8 plus or minus. Well, the square root of this parentheses squared is just what the parentheses is, the x plus 7. Over here, it doesn't show it, but square root of 8 is equal to square root of 4 times 2. You can extract the 4, and then you've got the square root of 2 left. So that's where this came from. Okay, and then, so now we take this 7 on the other side, add negative 7 here, add negative 7 over there, and we get x equals negative 7 plus or minus 2 square root of 2. Okay? And here would be your answers. And you could put this statement inside there instead of writing it twice. Excuse me, I don't have COVID. I just swallowed something I should have, or breathed something I should have swallowed. Okay. Here are some more problems, very simple. Square root of a squared is a, square root of 49 plus or minus is 7, so your answer is 8 plus or minus 7. Okay, on this one, take the 80 over to the other side, it's negative 80, divide by 2, it becomes 40. Square root of c squared is c, and square root of negative 40 breaks down into 4 times 10. So you have, I better write that one down. I'm getting too many steps. 2c squared equals negative 80. Divide both sides by 2, and I get c squared equals negative 40. Then I take the square root of both sides. And I really want you to show this when you do that, but when you do it, you got to do the plus and minus. Now, this is c. This is plus or minus square root of negative 4 times 10. That becomes I. That becomes 2. And 10 is 2 times 5, so it won't break down. So I just leave that as square root of 10. And now I'm going to reorder this. Plus or minus 2 square root of 10 I, making sure that this I is not under that radical. Or you can probably get away with writing plus or minus 2I square root of 10. Okay, now we're ready to move in using the quadratic formula. This is a formula you need to memorize. Okay? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? What this is this is your safety valve. You remember those problems that we worked factoring yesterday that we called prime, that you couldn't get an answer for them by factoring? This will give you an answer, although it'll probably contain either a radical, a square root, or it will contain an imaginary number. Now, there are some acronyms to remember this, like a bad boy couldn't make up his mind about, and it goes up. But you know what? It's easier to just memorize the formula. I can't memorize the acronym. Okay, so here we go. First problem. We started off with 2x times quantity x minus 3 equals 7. And we distributed the 2x here and here. And then we took this 7 that you can barely see back on the other side by adding a positive 7. So this is really the problem we're dealing with. Now we could try to factor this, and it might or might not. But we're going to use the quadratic formula. A is 2, B is negative 6, C is 7. I don't know why. Oh, yeah, C is 7. That refers back to that a squared plus ax squared plus bx plus c that we originally started with. Now, we're going to substitute that in here. There's something I would like for you to do for me. Anytime you're going to use the quadratic formula, I would like for you to write that formula out for me in its entirety in an unfilled out way. So I would like you to put this step in right here. Now, we're going to do the substitutions. Whenever you do the substitutions, I want you to use parentheses to show you what your substitutions is. Now, if this were a problem on a test, simply writing this would get you 1 point out of 4. If you got this far correctly, you would have 2 points out of 4, even if you totally messed it up after that. And the number of partial points you get on tests is all important. Now, let's go ahead and continue this problem. Okay, you can see here, a negative times a negative is a positive. Here's my plus or minus. Now, they didn't show this. The actual work on this is 36, because negative 6 times negative 6 is 36, minus 4 times 2 is 8, times 7. Okay, and then this brought down would be 36 minus 7/8 are 56. And this is how they got that. Now we can continue. I simplify this negative 20. I extract the I. 20 breaks down into 4 times 5. 4 extracts to 2. The 5 won't break down. Then we have the 4 in the denominator. So we've simplified it to this so far. Now we need to uncommon denominatorialize this, to use my words from the other day. Well, they did some simplifying first. They divided 2 out of everything up here because they could. Now they're going to cancel this 4. I would have done the common denominatorializing thing, and they carried it on. Here they've canceled the 2 and the 4 because there would be a parentheses with a 1 in front of it now. And you've got this. But because of that I, we have to put the answer in A plus BI format. So the answer then is 3 over 2. You can't see it right here, but there is an over 2 plus or minus I square root of 5 over 2. Right there's the 2 here. So I've got to write that. 3 over 2. In other words, we're uncommon denominatorializing this. 3 over 2 plus or minus I square root of 5 over 2. Now, why do we have to do this instead of just leaving it like that? Because anytime you have an imaginary number, you must put it in A plus BI format that we discussed the other day. Okay, here's an equation. We simplified some to get this. Okay. In this case, they're trying to divide every term by 2. This one's by completing the square, and we're not going to use this method. So ignore this problem. That I needed to remove that slide and I missed it. Okay, now we'll do one. This one has fractions in it. And do it by the quadratic formula. Well, you can work the quadratic formula with fractions. It will work. But I guarantee you, to use the words of the Cajun cook, I guarantee that it's going to be easier if you will clear the denominators first. Common denominator is 12. Okay, so multiply 12 times this, 12 times that, 12 times this, 12 times that. And these two cancel, so I end up with 5x squared. That goes once, this goes 6 times, so I end up with minus 6x. That goes once, this goes 3 times, so I end up plus 3 equal, and 12 times 0 is 0. So now I can put this thing in the quadratic formula. Negative b plus or minus x equals plus or minus the square root of b squared minus 4ac over 2a. So x equals negative, b is negative 6 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this becomes positive 6 plus or minus 36. 5 times 3 is 15 times 4 is 60, or 5 times 4 is 20 times 3 is 60, and it's going to be a negative square root of all over 2 times a is 5. So I'll have 10 down here. So I've got 6 plus or minus negative square root of negative, what is that? 14? No, 24 over 10. Six plus or minus square root of negative 24 over 10. So that gives me 6 plus or minus I times square root of 4 times 6 over 10, which gives me 6 plus or minus 2, because that'll extract I square root of 6. Square root of 6 won't break down, over 10, which gives me 6 over 10 plus or minus 2 over 10 I radical 6. Okay, I can do a little bit of reducing here. This reduces to 3/5 plus or minus. That reduces to 1/5 I square root of 6. Okay, and then we could put that in brackets if we wish. Now we need to use something called the discriminant. Now for this class, using the discriminant is not really that much done, okay? But it's going to be on the final, and it'll also be on my test. The discriminant is a predictor of what kind of answer you're going to get when you do the quadratic formula. Now, when you do the quadratic formula, you can have 3 different possibilities depending on this part right here. You noticed when this part was negative bigger than that, we got an imaginary number. If this part was smaller or positive when added to this, then we would potentially get two real numbers. And if these two came up to 0, then we would just get one real solution. Okay? Now, that part of this is called the discriminant. If this is 0, which is what I just said, there is only one real answer. Okay? Here's a problem. Okay, we've got this one. We're just taking this. The b squared is negative 10 squared minus 4 times a. The a is 1, and the c is 25. 4 times 25 is 100. Negative 10 squared is 100. So all of this equals 0. So when that happens, and you put it back into the problem, then you're only going to get one real answer. This is where they actually put this into the quadratic and worked it down. You get x equals 5. They just didn't show that. Okay? But this is just a predictor. When you see that, you're only going to get one answer. I think it might be worthwhile for me to show you why on this problem. So, x equals negative b plus or minus the square root of negative 10 squared minus 4 times 1 times 25 all over 2 times a, which is 1. Okay? That gives me 10 plus or minus square root of, just like what we had here, negative 10 squared. Well, I've already got it written out. So 100 minus 100 all over 2, which is equal to 10 plus or minus square root of 0 all over 2. And then this gives me 10 over 2 plus or minus square root of 0 is 0 over 2. 10 divided by 2 is 5. And that's just 0. So that's how they get that 5. Okay, the second possibility, which you can't read right here, if you get a positive value underneath that radical sign, then you're going to have two real solutions. Okay, in this case, b is 0 because there's no x term. Minus 4 times a, 1, times c, negative 9, equals 36. Okay, I've gotten a 36 here. If I wrote out the whole problem, okay, I'm going to have the 0 plus or minus the square root of 0 squared minus a plus, because negative times negative, plus 36 all over 2 times a, and a is 1, so over 2. Now, 0 plus or minus square root of 36 over 2, I just basically rewrote the same thing. Square root of 36 is 6 all over 2. Now, this breaks down into two problems. It breaks down into the positive side and the negative side. The positive side, I've got 0 plus 6 over 2 equals 6 over 2 equals 3. The negative side, I've got 0 minus 6 over 2 equals negative 6 over 2. In this case, equals negative 3. X equals. Now, it's just a coincidence that these two turn out to be the same number opposite signs. They do not have to be same number opposite signs. And I just realized I've gone way over time, and for that I apologize. So, if any of you have a question, you can write me a quick chat note. Otherwise, we're done for the day. I guess I got on a roll and didn't watch what I was doing. I'm just waiting to see if anyone has any chat comments. Under the chat, you can either make it a private or you can make it an individual with a little button out down at the bottom. At this point, I'm going to stop recording.